Hello everyone, welcome to my channel Hari PS videos. So let discuss or calculate some net force acting on the body or the resultant force acting on the body. So dear class 8 students, as we discussed, force has magnitude as well direction. In the topic we discussed that resultant force or the net force, how we can calculate the net force. If the two forces acting in the same direction, we have to combine this, we have taken addition. If the two different forces acting oppositely, then to calculate the resultant force, we have to differentiate them. If the two equal magnitude, the two forces acting equal magnitude and opposite direction, then we get the resultant force is equal to 0, then now let us calculate or find the resultant force for the following simple diagrams. Before that, let us understand one important thing is free body diagram. Let us understand what is this free body diagram. See, FBD we can termed as FBD, free body diagram. A free body diagram is a simple drawing used in physics to show all the forces acting on a single object. So a free body diagram is simple drawing used in physics to show all the forces acting on a single object. Simply we can say that the diagram which is showing how many forces are acting on the body is called free body diagram. It isolates the object from its environment and represent it is as a simple box or dot with arrows pointing in the direction of each force to show how it moves or stay still. It is isolated the object from the environment and represent it is a simple box or dot with arrows. So here it is isolated, it is separated from the environment. No other air resistance we cannot consider here. So we can represent with a simple box or with a simple dot, and you have to see some arrow marks, some arrows pointing the direction of each force to show how it moves, means in which direction the object is moves, or it will be say still at rest. Let us know. So resultant force, once again we have to recapitulate it. Resultant force or net force is the single force that produces the exact same effect on an object as all the individual forces acting it combined. Resultant force or the net force means the only single force acting on the body. How we get the single force? By taking sum of all the forces acting on the body. So individual forces are acting. So in this example, force of gravity, force applied, force of friction, normal force acting. So when we take all these sum, then finally we get only one force. That force we can call as a resultant force or the net force. Here normal force means any solid surface exerts some force on the object. When we place the any object on a solid surface, the solid surface exerts force perpendicularly or normally. Such force we can call the normal force. Force of gravity we know, then force of friction also we know. F applied. Force applied means how much force we have to apply in the form of either pull or push. It is the vector sum of all the forces in a system. Determine the magnitude and the direction of the objects. How much force is acting, in which direction is acting, we have to easily identify. Then, if the resultant force greater than 0, the object will accelerate in the direction of the net force. If the resultant force equal to 0 means the total force acting on the body is greater than 0, then the object can change state means accelerated. It means it starts to move. In which direction? The total force. The net force acting in a particular direction, in that direction the object will move. If the resultant force equal to 0, the object is in equilibrium. It will either stay stationary or continue moving at a constant speed in a straight line. If the total force or the net force or the resultant force acting on the body equal to 0, then no change will be takes place. If it is at rest, it is at rest only. If it is in the uniform motion, it moves with uniform motion. So these are the two terms very important for calculating the resultant force or net force acting on the body. So now let us calculate the net force acting for the following free body diagrams. First one, let us see. Let's see. Let us observe the direction of forces. First of all, let us know how many forces are acting here. Two forces. What are those two forces? 6 newtons and 2 newtons. So let us write forces acting on the object. Forces acting on the object equal to are 6 newton and 2 newtons. So acting from right to left, from right to left. So let us calculate F net or resultant force. Let us it's considered as F1, it is considered as F2. Two forces acting in the object same direction, so directly we have take sum F1 plus F2, that is equal 6 plus 2 8 newtons acting from right to left, then the object can move from left to right direction, okay. Then let us do the second one. Two forces acting as usually. One is acting from left to right, then other one is acting right to left. So force acting from right to left is equal to 6 newton. Then force acting from left to right is equal to 4 newtons. Let's consider this is the F1 and F2. How to calculate the net force or resultant force? We know that two forces acting on the object oppositely, their magnitudes are different. Then we have to differentiate the two forces for calculating net force acting on the object. and observe their direction. Observe their directions. So three forces are acting from left to right: 6 Newton, 10 Newton, and 4 Newton. Only one force is acting from right to left. So in this case, let us write forces acting on the body from left to right equal to 6 Newton, 10 Newton, 4 Newton. So total force acting from left to right equal to 6 plus 10 plus 4, that is equal to 16 20 newtons. 20 newtons. Then just we have to change the direction, free body diagram like this: 20 newtons and 8 newtons. Now, so total force acting 20 newtons from left to right. Then force acting from right to left equal to 8 newtons. 8 newtons. So now now calculate the resultant force or net force. F net is equal to, this should be considered as F1 F2. So F1 plus of minus F2, that is equal to 20 plus minus of 8, that is equal to 12 Newton acting from left to right. Left to right. So in this way we are able to calculate the resultant force or net force. Resultant force or net force. So we, by doing practice many problems. Then one more type of calculation, right? If the problem given like this, horizontally and vertically, whatever the problem you observed that acting only horizontally, either oppositely or same direction, whatever. But here in the fourth problem, have to see horizontally two forces are acting, vertically also acting two forces. So in this case we need to calculate horizontally as well the vertically. So first of all let us calculate vertically. Two forces, vertically upward 4 newtons, downward direction 4 newtons. So net force vertically directly taken 4 plus of minus 4, that is equal to 0 Newton. 0 Newton. Then horizontally. So left to right, how much force? 2 newtons. Right to left, how much? 5 newtons. So then calculate F net is equal to directly 5 plus of minus 2, that is equal to 3 newtons from right to left. In this way we are able to calculate or we are able to find the net force acting on the free body diagrams. Net force are the resultant force. So this is the one of the very important, how to we calculate the net force or the resultant force. So you have, the dear children, you have to practice many problems just by changing the values in your own problems. So try to solve, then simplification and finding net force or the resultant force become very easy. So thank you so much. Keep it up.